Hey everyone, quick question for you. When someone says AI, what exactly do they mean? Because here's the thing that's driving everyone crazy right now. You've got people talking about AI, machine learning, deep learning, generative AI, agentic AI. And honestly, most people are using these terms like they're all the same thing, but they're not. And if you're sitting there thinking, wait, I thought ChatGPT was AI, but isn't that also machine learning? And what's this agentic AI thing? You're not alone. This confusion is everywhere. So today I'm going to draw you the complete AI family tree. By the end of this video, you will know exactly how every piece fits together, why each and every layer matters, and most importantly, which one you should actually care about for your goals. We're going to start with the big picture and work our way down to the cutting edge stuff that's literally reshaping how we work and live. Let's dive in. Now let's move our focus to the whiteboard that I have prepared for you. So these are some of the areas that we'll touch upon during this video. So let's start with the artificial intelligence. So we'll start with the general concept of artificial intelligence, AI. Now AI is a broader term. The concept is to have a human level intelligence, right? So this intelligence could be either equal to the human intelligence or even more, right? So that's the goal. The end goal is to achieve AGI. What is AGI? AGI is artificial general intelligence. The idea behind this is to have equal or greater intelligence than humans, right? So that's the general goal that everyone has in mind. And this is where we are going towards. Now that we have looked into what AI is and what AGI is, which everyone is trying to achieve at this point, now this is a concept. We want to dive further into how we can achieve this, right? So in order to achieve this, we need machine learning, right? So ML, right? So that's where everywhere you're seeing these terms tossed around is AI ML, right? So the AI is that concept that which everyone is after, and machine learning, it provides you the tools to achieve that end goal that everyone is after. Now, as the name suggests, machine learning or ML both has the two words there. One is machine, which is, you can think of this as computers or robots, and the other one is learning, right? So it helps robots or machines or computers learn to achieve that artificial intelligence, right? So what are these tools? These tools could be in the form of models, right? So we create some model which caters to a specific use case, or we provide these models then the training data. So that's another important piece of this whole puzzle, right? So machine learning comes with the training data. You need to have validation data. So there's a whole field when it comes to machine learning, but on a high level, machine learning provides you the tooling to create a machine learning model which you can use, which you can train based on the data that you have. And once you train that and for a specific use case, you will then be able to achieve the artificial intelligence that you're looking after. Now, under machine learning, there are three main concepts that we'll briefly touch upon, right? So machine learning, there are different types of machine learning, right? So we can categorize this mainly in three different areas, right? So one is the supervised machine learning. What is supervised machine learning? So supervised machine learning is something that you supervise, as the name suggests, right? So you supervise the whole machine learning process as a human. So there's always a human involved in this loop. Let's talk about an example for this. Like, for example, you have a use case where you want to identify between an image of a dog or an image of a cat, for example, right? So you have these two images. You want to train your computer or the machine that you have, either that would be a real robot as well, to understand whenever I give an image of a dog, it needs to identify it as a dog. But to achieve that level, you need to make sure that you train your machine learning model. And in this case, you supervise, right? So how do you supervise? You give a list of training data, and then you label images of dogs that you are adding that as a training data, and then images of cats as cat, right? So this is the labeling process, right? Where you label cats and dogs, the images of cats and dogs. And then based on this, once you train your machine learning models using this supervised mechanism where you are actively tagging the training data for the machine learning to be able to make the decisions on. Now, once the model is ready, then you can give it as an input any image, and it will identify that as a dog or a cat. But what happens if you give a new image which doesn't look anything like a dog or a cat? At this stage, this will fail, or it will give an incorrect answer. This is a bird, and this supervised model will fail at this point because it was trained on two sets of data. One was the images of dogs, and the other one set was images of cats. Now, the next category of machine learning is the unsupervised machine learning. So this is where you just give a set of images. This unsupervised machine learning model, what will do is it will give you a cluster of what it thinks that these images are related. Now, for example, you are adding to this machine learning the same, right? So for the training data, you added bunch of dog images, bunch of cat images, and then bunch of bird images that you are training your machine on. Now, at the end of this training, it will identify that there is a pattern, right? So in this case, it would say that I see 3 different clusters of data. Right? So in this case, you can then identify that, okay, I think there would be 3 types of animal images that we are seeing here, right? There would be some outliers, and you can identify those as well. But what would be the right use case for this, right? The supervised machine learning is the right use case where you already know when you are, as a human, are adding these inputs and training the machine learning model. Unsupervised machine learning is helpful in cases of, for example, you want to understand shopping behavior for your customers, right? So in this case, you would be able to understand, okay, these are the 3 different clusters, and possibly there are some male customers and there's some female customers, and there's some additional age-based cluster, which is totally different, possibly younger people or older people, right? So in this case, you would be able to identify these clusters, and you can then understand these specific behaviors which are correlated together. Now, there are other different types of machine learning, like reinforcement learning, but I will not go into those discussions. I would now go into another important area, which is the deep learning. Now, deep learning mimics the human brain. So there's an input and there's an output. In between, what happens, we don't know. What it does is that I'll show a quick example for this, right? So how it actually performs. So in this case, you can see there are a bunch of nodes, right? So this is the input layer, and on the right side, you have the output layer. And in between, you have these hidden layers, right? So think of these hidden layers as a small robots or some kind of processes that are being executed, but it's hidden from us, right? What it does is, let's take an example, right? So you started with an image of we start with an image, and we say it's a cat or a dog, right? So if you start with this question, if it's a cat or a dog, right? So this would be our question. And maybe I'll lock this for now so that we can play around with this. So he started with this question, it's then with an image, and we are saying if it's a cat or a dog. Now, all these nodes that you see under the hidden layers. So for example, it might then, each node would, as human brain works as well, right? So for human brain, these set of neurons, which makes the decision based on some of the features that they're actually observing in an image, for example, right? So let's take us as an example, where if you see an image, the first thing we'll see, how does the eyes look? Does it match with which type of animal, right? Then we might look for other areas as well. Legs, right? So how many legs does the animal have? And then we'll go into further kind of investigation. Does it have fur or not, right? And based on all this, there will be multiple layers that we make that decision. And based on that, we give some probabilities to what would be the right answer. So it goes through these multiple smaller decision-making processes. Maybe we also talk about the ears, right? Or possibly the color, right? So all this would be smaller decisions that we do. And at the end, we will come up with a decision, dog or a cat. And then each of these would have a probability. There's some kind of weightage where we see, I think, 99% sure that it's a cat, right? So the same way we as humans make this decision, and it's the same for these machine learning models. These hidden layers, it could look for multiple features, but it would be a very quick decision, as we as humans are also doing that behind the scenes, but we're not aware of this, right? So we're looking at each of these features and make that decision. Now this is deep learning, and it mimics a human brain, as we talked about. Now let's take a step further. Generative AI, or simply put, Gen AI. Now, generative AI, arguably, it can be put under the deep learning hierarchy, or possibly under the machine learning hierarchy, because it mimics some of the components of each of these areas, right? So that's why, to me, it's my personal opinion. Correct me if I'm wrong in the comments, but I think it has a lot of similarities with deep learning. What generative AI does is that it gives you the next available sentence, the next available paragraph, or even the whole content, right? Or a book these days. So there are some similarities, but I would not say it's exactly a field of deep learning. But let's talk about what generative AI is, and then maybe you can make your own opinion after that. Now, generative AI, there's a key piece to generative AI. So what is that? The foundational models, right? So this is an important concept. Think of this as any machine learning model, but it generates, right? So this it could help you generate text, image, videos, or any other thing that comes to mind these days, right? So these are the high level, the three different types of content that it generates as of now. Now, when it comes to generating text, language, right? So we have a specific concept that you also have heard are large language models. So these models understand human language. These models were trained on tons of data. So they input text and they understand the language, and it will provide you a response either in text, or in some cases, we can create images or videos. We are expanding these foundation models where these are multimodal foundation models, where you can input a text, you can input image, you can input video, and it will generate, based on the prompt that you give, it will generate a specific output. It could be in the form of a text, image, video, or even audio as well. I missed that. So audio is an important piece these days, right? So with these recent foundation models, it also generates video with audio, right? So that's a breakthrough that we're seeing across the industry. Now let's quickly talk about what different types of large language models that we have in industry, right? So on a high level, we have a few, right? So we have, for example, GPT, right? So this is, everyone knows about it, right? So with ChatGPT, everyone knows about these GPT models, GPT-4, GPT 3.5. Then we have from Google, we have Gemini model, right? So we have these multiple types of Gemini models, and every model has its own characteristics, and how it was trained on. It will, and depending on what input it accepts, what are the output it accepts. Then from Amazon, not a lot of people are aware of this, but Amazon has their own models as well, called Noah models, right? So it can generate videos, it can generate text, images. So there are multiple types of Noah models. And then finally, and most importantly, we have Claude, right? So Claude is something which is also a large language model. It provides, there are multiple versions of Claude, and this was developed by Anthropic, right? So the GPT-4, GPT-4o, all these models are OpenAI, the top one. Then we have Google, then we have Amazon, and then we have Anthropic. And there's so many others, like Meta is going towards that open source model. Like if you think of this as the operating systems, right? So for example, Andrej Karpathy, in one of the sessions that he had recently, he talked about these large language models as operating systems, right? So in this case, these closed source, all of these which I mentioned, we can compare these with Mac OS and then Windows, the Microsoft Windows operating systems. And then we have some open source models that Meta specifically are creating, which are open source. And this is in alignment with what we have seen in Linux distributions, which are open source. So it's kind of the two main areas that we are heading towards. Now let's talk about something very briefly, and then we can wrap this up. But in the next video, we will talk about these individual areas and see how we can build even further. And if you are interested in a specific topic, And if you're confused about what is the difference between, for example, large language models and agentic AI and things like that, we can dive in even further. But to quickly talk about one area that I've seen a lot of people asking me about is, for example, large language model, what does it do, right? So in simple terms, it has an input, right? And then it has an output, right? So input could be in the form, as I mentioned, it could be any image, text, or video or audio. And the output would be in the form of the same, depending on the model itself, what model that we're talking about. It could be, let's categorize this as foundational models, right? So instead of not focusing on a specific large language model, so that's the idea behind this. Now, this was already trained on a vast amounts of data. However, there's always a gap how much amount of data it was trained on and how recent that knowledge is, right? So that's why the recency is a big problem, right? These days we are solving that with additional tooling. So we have the model context protocol, or simply put, MCP. This actually provides you that additional tooling to be able to fetch what you don't know about. Like, for example, these models, if you ask them, what is the current date? They will not be able to answer that because it will only give you the date it was trained on. Then you can use these model context protocol. I have a separate video for this as well. And these model context protocol can have, for example, clock integrated or time integrated with it, or it can have an integration with weather API, right? Or it has integration with news, right? So all this can be achieved. And then more importantly, these days we're also seeing integration with search, right? So it can search on your behalf, right? So when you add this additional power to your foundation model, this becomes an agent. But we still have involvement when it comes to you're adding an input and you're expecting an output, right? So you, in all these things, there's an input from a human, right? Now we're going towards that AGI, agentic AI, where in that future we are removing human from the loop altogether. So this whole mechanism, right? I'll just move it to the background. This whole mechanism would be handled by an AI, right? And that's where we are going towards that agentic, when we remove the human from this whole process. Of course, the human will create this whole mechanism, but once you do that, let's take an example, right? So for example, you want to create a trading application, right? I want to trade the stocks, but I can just simply give the rules to my foundation models, give the appropriate tools to make API calls to trade on my behalf. I've already created, by the way, another video which has this integration. So you give the rules to the model itself, and that model would automatically look for the past, what it trades that it did, what positions that it has open, and it will automatically make the decision based on the tools that it has. And it will automatically do that until I stop that whole process altogether. So this is what agentic AI is, and this is where everyone is heading towards, where we are removing that human in the loop so that it automatically makes a decision on your behalf, given a set of rules that you provide. Now, this is a broad topic, but I want to keep this video short. And in the next videos, possibly I will dive into this concept. If you like this content, please like and subscribe. And until next time, thank you so much.